Alright, let's go ahead and go through our homework. Here we needed to determine if the sequence is arithmetic, and if so, the common difference. All three of these are. On the first one, I'm subtracting 3. On this next one, I'm subtracting negative 30. And on this bottom one, I'm subtracting 2. So those are my common differences. Given the explicit formula, find the first 5 terms. So that just means I plug 1, 2, 3, 4, 5 in for n. And then to find the 34th term, I plug 34 in for n. Here, they're telling me that my first term is 28 and the common difference is 10. That means that the difference between the first and second term is 10. So 28, 38, 48, 58, 68. Write your equation. I gave you this equation in class. It's also in the notes. I used a T instead of an N, or T instead of an A. That's not a big deal, but we've got the important pieces of information. Just plug in what you know and simplify. Same thing for number 13 here. You're starting at negative 34. That's my first term. And you're going to be going down 10. So negative 34, negative 44, negative 54, negative 64, negative 74. You have your first term and your common difference. You can come up with an equation. Here, I needed to find the first 4 terms. I know a couple people in class had trouble with this because there's an n in the numerator and the denominator. Don't overcomplicate it. You're just going to put 1 in for the numerator and the denominator. Then for a sub 2, put 2 in for the numerator and denominator, and so forth. You should get 3 5/8, 7 27ths, and 9 64ths. On the next page, you had to determine if it was geometric and find the common ratio. Well, not all of these were geometric. 2 and 3 were not, so there was nothing to do there. Number 1, I'm multiplying by negative 6. On number 4, I'm multiplying it by 5. On number 5, I'm multiplying by 2. And number 6, I'm multiplying by negative 5. On number 7, I was given the explicit formula, and I need to find the first 5 terms and the 8th terms. That just means I look at my n, and I'm going to plug in 1, 2, 3, 4, 5. And then for the 8th term, plug in 8. And if you look at the pattern there, 1, 3, 9, 27, 81, that makes sense. I'm multiplying it by 3. On number 9, it's the same situation. I'm going to plug 1 in for n, and then repeat that pattern for 2, 3, 4, 5, and also for 8. On number 1, I need to write the first 6 terms of the sequence. Well, my first term is 1, so I'm just going to start by writing 1. And then it tells me that I take the previous term and add 5, so 1 plus 5 gives me 6. 6 plus 5 gives me 11. 11 plus 5 gives me 16. 16 plus 5 gives me 21. 21 plus 5 gives me 26. On number 5, we've got a square term there. Don't let that throw you for a loop. My first term is 1. 1 squared plus 2 is 3. 3 squared plus 2 is 11. 11 squared plus 2 is 123. 123 squared plus 2 is 15,131. All right, on number 7 through 13, I needed to write a recursive definition. So I started by listing what my first term was here. It's 32. So t sub 1 equals 32. Then I asked myself, well, what's happening? Well, 8's being subtracted. So I took, to get the 24, I took the previous term and subtracted 8. So that's where that t sub n minus 1 minus 8 comes from. On this number 9, my first term is 2, so I listed that. And then I asked myself, what's happening? Well, it looks like it's being multiplied by 3. So to get 6, I took the previous term and multiplied it by 3. T sub n minus 1 times 3. Number 11, my first term was 21, and then I was dividing it by 3. You could put divide by 3 or 1. I said multiplying by 1/3. It's the same thing. Number 13 was probably the challenge problem on here, because to get this one, it's really neither arithmetic or geometric. 2 plus 3 gives me 5, 3 plus 5 gives me 8, 5 plus 8 gives me 13. The next one would be 21. So on this one, I actually have to list the first two terms. T sub 1 equals 2, T sub 2 equals 3. So those are the first terms. T sub 1, T sub 2. And to get the third term, I'm taking the two previous terms and adding them together. So that means the previous term and minus 2 would be the one before that. If you got that one right, give yourself a little pat on the back. On 15 through 17, they're giving me the recursive. Oh, I need to write a recursive. They're giving me the explicit, I'm sorry. So what I did was I plugged 1 in to get my starting point. 5 plus 2 times 1, and I got 7. And I went ahead and I figured out the rest of the pattern, plugged 2 in, then I plugged 3 in. Looks like I'm adding 2 each time, so I'm taking the previous term and adding 2. On 17, I plugged 1 in for n, 2 in for n, 3 in for n, to kind of get the pattern. Looks like I'm subtracting 13, which makes sense. List the first term, subtract 13. I did the same thing for number 19. I plugged 1 in for n, 2 in for n, 3 in for n, and then I went ahead and figured out what was happening. It looks like it's being multiplied by 7, which makes sense. My base there is 7, so my starting point was -2, multiplying the previous term by 7.